All right, so yesterday we had to stop in the middle of a problem, and I didn't come around to check to see if you actually did it, but I'm just going to catch us up here. You were asked to find all the roots of these. So my first question is on part A, I said, hey, list all the possible rational roots. How did we get these numbers is my first question.
All the things of 4 and 6.6.
Okay, so be more specific. These are factors of what? And what is the constant on our problem? So these are factors of, and I don't really care about the negative because of plus or minus, but I agree with you. It is -4. And this denominator piece came from factors of what? So factors of LC, and that was a 6 in this problem. That's where those numbers came from, just to kind of refresh on it. Every time they'll come from these. Now, I'm going to hook you guys up. Instead of making you do a bunch of synthetic divisions that don't work, I will point you in the right direction here. So here is my advice. We'll try this. And this is the most important part, and we're going to refine this even more. But we did the synthetic division, and it gave me a 0. The fact that it gave me a 0 meant that it was a root. That worked. So this is where we're at. This is my other part. Now, at the end of the hour yesterday, because I think we went all the way to the bell, right? Or until 3:15. I think that sounds right to me. Okay, here's how I normally present this. Right now, if we wanted to, and I want you to tell me if this is true, if I wanted to rewrite f of x, which originally was this, we found one of its factors. What were one of its factors? X, and I can see it on the board somewhere. So that was a root. So that's what this is. I agree with you. If x equals -2/3 is a root, what was the factor that we identified? X plus 2/3. That was my factor. Now, for this, if we write it this way, and there's lots of reasons that we would, here is the factor that we got. What is the other factor that we still have to deal with? Like, here's one of the factors, and the quotient is the other one. Always, it'll work that way. And we've already written it, and it was this. Sorry, 6x squared plus 9x minus 6. So right now, I have a new way to write my function f of x. That's all that I'm seeing. This one, I would not say is entirely factored, but it's getting close. Okay, so we're going to dig in with this. And I know I'm writing it a little bit differently than we did yesterday. I'm just trying to really make the connection that these factors just give us a new way to write f of x. So one of my factors was x plus 2/3, and I'm going to switch colors for this next part of it. And we're only going to look at this one, because this was what I asked you to factor. What's the first thing we would always check? GCF. Is there a GCF between these? So I'm going to write it here. Is that still saying this times 3 times this? Okay, and what would stay inside? 2x squared plus 3x minus 2. Okay, now this 3, it can hang out, it can move. These are all just being multiplied. So in my mind, it is way more natural to put it out in the front, but it's not a requirement. I think this looks kind of wonky. One more time. I didn't understand you. I'm sorry. Yeah.
I think she should excuse me now.
Excuse or speak? Depends for how long. We'll deal with that. I'm just going to ignore it for now. Okay. Do you guys agree that this is a more natural way to write it? Whether you do write it or not is up to you. Does this feel more natural? Or does it seem like magic just happened?
Yeah.
Like, this looks much better, I think. Now, that's purely stylistic choice, and maybe I'll get rid of this denominator here in a second. But these are the same, right? This times this times this is still this times this times this. Okay, let's look at this one a little bit more then. How do I factor it? What's, like, we already did GCF. It's not a binomial, it's a trinomial. What do you mean 2? So we've already done the GCF. We took it out already. So we did do it. There's no more. I would agree. But how do we keep factoring? So group it. I like that idea because it's not a leading coefficient of 1. But how do I group? So 2 times -2 is -4. And now I need factors of -4 that do what? Can you find me 2 factors of -4 that add up to 3?
plus 4.
Negative 1 and 4. 4 times negative 1 is negative 4, and 4 plus negative 1 is 3. Yep, those work. Okay, so I'm going to let these come back in just a moment, but let's rewrite this. I'm going to rewrite my 3-nomial as a what? Not a 5. I'm going to replace this 3 with how many numbers? 2. So it's going to be a 4-nomial. So let's do that. Just this one is all I'm looking at right now. 2x squared minus x plus 4x minus 2. These are the same thing right here and right here. We're just rewriting it. If I put parentheses here and here, we still have the same thing, right? What comes out of this? And it leaves behind a what, Jade? Okay. Plus, what can I take out of this to ensure that I leave a 2x minus 1? A 2 and a 2x minus 1. Can I see both of these factors right now then? Okay. Now, I'm going to be, like, it looks weird because we're doing it inside, and normally I might do some scratch work. But let's see. We had a 3 and an x plus 2/3. And what are the other two factors that we just got from this? 2x minus 1 and? Okay. At this point, whether we wrote it like this or not, we have all the factors of f of x. Now, just to make the language nice, and it's not exactly what we're doing on this problem because all we're doing is finding the roots, but I'm just going to make a note here. If you're asked to find the factored form of f, this is it. This is completely factored at this point. Everything has been broken down as far as possible. And the reason that we do this is because it's so easy to find my roots at this point in time. So let's do that. We already know one of them, but if you happen to forget it, we're going to hit it again. Each of these, to find roots, I'm going to replace f of x or set all of this equal to what? 0. So I'm not going to write the 0, but that's what we do. Is there a value of x that makes this equal to 0? Jade claims negative 2/3. Can somebody second that that's what I get here? Yeah, I agree. If we set this equal to 0, we just subtract 2/3 and we're done. This one, I'm going to talk it out. I would add 1 and then divide by 2. Add 1, divide by 2, 1/2. How about this one? Negative 2. Now, we are done because, and I know it feels odd sometimes because we've done this and then kept doing more, but if we look at the example, what did I ask us to do? Is that really what it says? List all the roots and find all of them. We listed them. Did we find 3 roots right now? So now let's just double check. I claim that negative 2/3 showed up. Do I have any evidence out of these numbers? Could I make a 2/3 out of these? Yeah, it's a 2/3. It's this and this. So that one showed up. Yes, Ken?
Well, we could try other numbers, right?
We wouldn't, and you won't, because I'll give you the one to try. Okay, so negative 2/3, I've just confirmed it was on my list. It showed up here. That makes sense. Is 1/2 a possible number on my list? A 1 here and a 2 here? Yep, that one was also reasonable. It showed up. Is negative 2 on this list? Now, I know negative is just plus or minus. Is a 2 here somewhere? 2 over 1. There's my 2. Now, all those numbers that we just found happen to show up exactly here. That's not a coincidence. It will always happen this way. Okay, as we're looking at these, the whole factoring process, the hardest part for our stuff is going to always be finding the guess that we take first, but we don't have to guess anymore. No more guessing needed. Kind of. Should we do another one like this? Okay, before we do, questions about any part of this. Preferably you would have asked before, but now is also fine. Just give me thumbs up or thumbs down for yes or no, okay? I can do synthetic division to verify that this is a 0. Okay, synthetic division is super easy if you struggle with it. Just come talk to me. We can clean it up. Okay, I can factor the GCF out of this. Still doing up or down. Okay, I can group this to factor. Like this is grouping, this whole process right here, all of this is grouping. Okay, I can set each of these equal to 0 and tell you what the x value would have been. Okay, very interesting how this has changed throughout people, which cool, it's good that we're spread out. Okay, we're gonna make a couple comments, we're gonna do one more problem, and then the rest of the time we get a couple little theorems. So to start this, we're gonna make some comments real quick. So helpful, I was gonna say helpful. Okay, just to make sure we have these, we're gonna say the following are all equivalent. Roots, give me another word that I might ask for a root. So roots, and this is a new symbol. I don't care if you use it, you can say is equivalent to. An equal sign with 3 bars means equivalent. We don't, it's pretty rare, but instead of me writing is equivalent over and over, I'm gonna use this. Roots are the same thing as what? And you could just use equal, I guess, for that sake. Solutions. Give me another thing that's the same as. So you would use grouping to find these. Roots, solutions, there's 2 more words. Zeros and x-intercepts. Okay, these are all the same idea. Now, that can be misleading, and you're probably thinking, well, why the hell would I need 4 different words for the exact same thing? And just to really exemplify that, if I wanted to say I had a root, it's going to look like this. X equals, well, I'm just going to make up a number, okay? Out of nowhere, arbitrary choice. X equals 3. That's what a root looks like. If I talk about a solution, we could get the same root, but it's when it's a solution to setting f of x equal to what? Nope. If I'm going to find the solutions, it's when I set it equal to 0. And that might lead us to the fact that x is equal to 3. So my solution can be the solution to this equation, but we can call it the root. The 0 itself, same thing. This one's going to look just like a root. It's what we get when we set it equal to 0, why the name comes from there. The x-intercept is a weird one. What would the x-intercept be if we're writing it? So root, it's a solution to this. It would be a point. What's the x value of this point? 3 is the x. And what's the y value? 0. Okay, these are the 4 versions. All of these are the same. These are all going to produce the exact same stuff. It just depends on the context and how we write them. Okay, the other big part. And we're going to use, I've been wondering what this light was all day up on the ceiling. It's clear, my watch is? Yeah, I will, my bad. Okay, for this, everything that we talk, like there's very few math things that I do in here that I don't consider super important. This one we're going to see so frequently that like lock in for this one for a moment. Okay, check it out. I'm going to make a claim. X equals, do you want me to use a real number or do you want me to use, can I use a letter? Like I'm going to use P. X equals P is a root if and only if, which just means both directions. If this is a root, then we get something. And then whatever that something is, if we get that, then it's x equals p. Okay, this is a root if and only if. This doesn't look like a factor right now. Would you agree? But when we get a root, it's from setting the factor equal to what? Good. Could you make it so that instead of x equals p, that there was a 0 over here? How would I move this p over? So I can't divide because I would say x over p equals 1. But I like your head, like where you're thinking that, where your head is at, weird. I like where you said add or subtract. Is this positive or negative right now, though? So if I want to move it, what do I have to do? Good. Okay, this I think is the biggest connection piece. If x equals p is a root, then x minus p is a what? This doesn't look like a root anymore. It looks like something other F word that we use. So those, I like factor, but that was also a good one. This is what factors look like, x minus p. And there might be other numbers in here, but here's the big deal. And this one is up to you if you write. It's not going to be super nice and wordy. Are these really any different? Like if I give you a root, is that any different than if I just gave you a factor? So they look different, but am I really giving you any additional information or any different information? Like they're the same, right? These are not quite synonyms, but they are the same. If I give you a root, you got a factor for free. If I give you a factor, you get a root for free. We can move between them super easily. They're the same concept, just written differently. Well, if we're thinking about functions, I would say part of a function. Yeah, but like check this out. If x minus, and we'll just like, you don't have to write here. If x minus 3 is a factor, when you set it equal to 0, what is it going to give you as a root? Cool. If x equals negative 2 is a factor, or root, sorry, what's the factor I get out of this? Almost. X minus a negative 2, because we would just add that to both sides, right? Or x plus 2. We can go between factor and root easily, every time. These are the same thing. They're just different interpretations. Do I need to like say that 10 different times in 5 different ways? Or factors and roots are the same. Interchangeable, if and only if. We move back and forth, no problem. Do you guys remember what this means from geometry? So check this out. I'm going to write it in if and only if real quick, and this is going to be just a side trip. I'm trying to think of a silly statement I can make. If I'm in, so this is from your perspective, okay? I'm in Algebra 2 if and only if I'm having fun. Okay, so check this out. This is a math idea, but because if and only if showed up, I'm going to just readdress it. If you saw it in geometry, I guarantee you did. I don't know how Ms. Osmond taught geometry. I didn't ever get to go to it. But check this out. This says 2 things. If you're in Algebra 2, then what would we conclude? Yeah, then you're having fun. Of course you are. I'm just going to say smile for having fun. Now, the flip side may also be true. If you're having fun, then you're in Algebra 2. Like, it fits hand in hand, right? Cool. Okay, it just goes both directions is the big deal. Okay, let's do this with one more. And are we doing it together? Am I going to give you one on your own? Because it's going to dictate how gross the problem is. Okay, together. So we can make it a little bit grosser then. Like, not terribly gross, but we're going to look at one. So let's go ahead. We're going to do the same thing. Did we just have example A just now? A? So we're trying to find all the roots. So we'll just do another example. Find all roots of, and here we go. Let's say that our function this time is this wonderful f of x equals, and I got to do it so they're nice roots. So give me 1 second. Okay, so here we go. F of x is 6x cubed minus 7x squared minus 30x plus 16. Okay, I'm not going to break down this problem into the 2 parts as before. We're just going to run with all of them. First off, it's worthwhile since there's 4 terms. I'm going to think about grouping. Like immediately, if there's 4 terms or 6 or 8, I'm going to let that cross my mind. If I put parentheses right here around the 6x cubed and the 7x squared, what's the common factor? So nope, just here, x squared, right? And it leaves behind 6x minus 7. Is there any chance that I'm going to leave a 6x minus 7 behind here? Like no matter what I take out, it's just not going to happen, right? So that's me trying grouping. If it had been the same, I would have pursued that option, but I can't group it. Okay, so that means, bummer. Could we realistically guess and check? Do you want to just randomly guess and check? Like what would be your first guess if you were to guess and check? So 0 doesn't work, and maybe like there's no right answer there. But if it were a 0, it should give me 0. 0 plus 0 plus 0 plus 16 is not 0. So 0 didn't work. Bummer. Others? 1. 6 minus 7 is negative 1. Minus 30 is negative 31. Plus 16. Now, I think I messed up. Nope. That's also not 0. Negative 1. Negative 6 minus 7 is negative 13. Plus 30 is not negative 16. It's not 0. Like, there's an issue here, right? Like, we're just going to keep going pretty much forever. Would you agree? Yeah. So there's value in having a good kind of educated idea of where we should try. I want you to help me figure out where should we check. Now, I'm going to word that differently because now we're actually jumping in. I want us to find what numbers are worth checking. The possible, what does this symbol mean again? Quotient, and a quotient comes from a fraction, and a fraction is a ratio. They're the rational numbers. I wish that there was a nicer way to get there other than taking those steps. Okay, I know that these possible roots are going to have some form, plus or minus some fractions. Where do I get the pieces of these fractions? So like I'm trying to find what numbers are even worth checking. So change the order. PQ. Where does this P come from? Constant. What are the factors of 16? Does 1 go into it? Does 2? 3? 4. 3 does not. 4. 5? 6? 7? 8? Okay. Those. These are all the possible factors of 16. The P in our PQ list are factors of this term. What about the Q's? They're factors of 6. 1, 2, 3, 6. I'm always going to go in order, just so you know, Kian. Like if you skip one, you could be in trouble because maybe it's the one that you need. Okay, now if I just looked at these, there's a lot of them. Like, and it could be worse, but it could be 1 or 2 or 4 or 8 or 16. Notice we didn't even check 3, which that's fine that we didn't, but there's no need. It won't happen. Or it could be 1/2 or 2/2. That's just 1, or 1/3 or 1/6, and then we can just keep going, right? Like we can hit all of those possibilities. Here's the awesome part for you guys. I don't make you do all the synthetic divisions. I want you to try, and I'm going to even add something to it because I'll make it so this problem doesn't just feel like I'm doing it for you. Find all roots of this given, and I'm like, this yellow part is just a more clear way to word it, I think. 3x minus 8 is a factor of f. Okay. Now, the value here, it's not as meaningful if I'm going to give you the number, but it's a calculator issue. Not that, like, we can do it. I just don't really want to make you guys do a bunch of synthetic divisions, and I don't have enough calculators for everybody. Okay, so if this is a factor, first of all, do you believe me? Even if you believe me, you should trust but ver. You guys might have ever heard this. You ever heard trust but verify? So if you ever hear something, like if you hear something on the news, I should probably, like if it's on the TV, I'd probably trust it, kind of, but I should verify it, right? Like people can mislead and all that. Always trust but verify. How would I determine if this really is a factor? So I like the trust part, but how does the verification happen? If this is a factor, we could either plug it in, or we could, what did you say, Jade? Yeah, let's verify by dividing. I'm sorry? I just gave it to you. Just me. I gave it to you. 8/3 is in this list. Yep. So I'm just telling you one that I think will work. Verify by dividing f of x by what? So maybe you can do it synthetically if you want, but what am I actually dividing by? So here's f of x. It's this big monster. Not just 6. If I made a claim 3 is a factor of 18, what division would you do to get the other factor? So I'll write that one. I'm going to make a claim. 3 is a factor of 18. How would you verify that's true? So you did multiplication, because that's an easy number. Could you do 18 divided by 3? And you get 6. And what would your remainder be? 0. Let's do that. Let's divide f of x by this thing, 3x minus 8. And see remainder 0. And if it is 0, that's a good sign. If it's not 0, it means either I picked a bad problem or you made a mistake. Now we get to choose. We can do it one of two ways. Do you want to do it synthetically, or do you want to do long division? Okay, there's a trap waiting for you.
Oh, never mind. No.
Why?
It's more than 1.
If we're going to do it synthetic, that number needs to be a 1. Now, we could make it work, or we can do some long division. Preferences. Okay, so here we are, long division. Let's do it. 6x cubed minus 7x squared minus 30x plus 16. Now, I'm not saying it, just so you guys know, I'm not writing, like I'm not saying these words or numbers, terms, as I'm reading it for your benefit. I'm doing it so that in my head, I actually have the time to think and run through, am I missing any powers? I didn't skip any, I'm okay. Okay, I'm going to put that dividend, and what's my divisor? That's my dividend. What am I dividing by? My divisor. There it is. Okay, who is queen? Yes. Okay. So what? I underlined it. That's important. What do I do with it?
Find how. What to multiply by to get.
What do I multiply this by to get 6x cubed? 2 2x squared, I think. I'm going to write it above the x squared. Now what? There we go. So I'm going to multiply through, right? Okay. 6x cubed minus 16x squared. Why would I put parentheses around it? Bet. And are you guys okay? I'm going to pause it. I want you to finish the division. I'm going to give you a moment. If you struggle with it, let me know. I can, I'm going to give you a head start, but I'm going to start putting steps on the board. 2x? Just 2, I think. Because I just need these all to match, right? 3x times what to get 6x? Well, it's 2. 6x minus 16. What happened? It would be negative 6x. Thank you. So that's a minus 2 there. Yep, I noticed something was wrong. Thank you for finding it. So negative, and then that's there. There we go. Okay, do we get a remainder of 0? Okay. Now this part, again, it's not really the main focus of what we're doing, but I can't, we have to address it because it's going to stick in our heads if we do this. We know we're looking for the roots, which means I need to factor everything eventually. But right now, from this, what I normally do, from what we've just found, I think I can confidently say that, yes, this was a factor. So if I wanted to write f of x factored, one of the factors is 3x minus 8. And what's the other factor? So right now we have these factors. And then we just need to look. And I'm going to let you guys do a little bit of factoring, but I just want to make sure we're all on the same page. Does this one right here factor any further? The 3x minus 8. No, it's just linear already, right? We can't break it down any further. Now, even if there was a GCF, I wouldn't really care if there was a GCF. We could do it. I'm going to do some scratch work over here this time, just so it looks a little bit nicer. So I'll just really clearly scratch. Which one of these pieces do we need to factor further then? So let's do a little bit of scratch work here so it looks a little bit nicer. And I want you guys to factor. Didn't we just do this exact same one? Yeah. That is so weird that it happened that way. Weird. Total coincidence. -4, and that's a 4 and -1. So 2x, and it looks like x minus 2. And is it plus 2? Yep. And minus 1 and x plus 2? Is that correct?
2x minus 1.
Hey, I'm trying to learn how to factor in my head because I never learned it, and it's finally starting to happen, which is weird that now of all times. Anyway, I just did grouping, happened to be the same as one we did before. Can I write this as a more factored form then? Yeah. 3x minus 8 is one of the factors. What's the other one? Or the other two? 2x minus 1 and x plus 2. At this point, I have it completely factored. This is the most factored that my function f can ever be. Can I get the zeros out of this pretty reasonably? So help me out here. I think I can see there are 3 factors, and in turn, there will be 3 roots. If you set this equal to 0, what root would it give us? We add 8 and then do what? So add 8 and divide by 3. There it is. For this one, and I should have checked this a long time ago. When I'm doing that comment, a couple of you guys pretty regularly give me the words that I'm expecting to hear. Is there anybody that doesn't really know what I'm doing when I'm saying those things? When I say add 8 divided by 3, do you know where I'm looking and doing? So if it's not clear, I should have asked this a long time ago, but just to be and it's going to be obvious here. If I said, let's solve this, everybody agree the first step is add 8? And then in my head, without writing it, what's the next step? Okay, just to make sure we're all in the same, that's all I'm doing. I'm just thinking out loud about these. Okay, this one I'll add 1 and divide by, which is 1/2. And this one I'll do what? Subtract 2. Okay. I just found all 3 roots. And that's the whole question. Now, we get 2 more really quick theorems. And one of them, I'm going to be honest, we're going to skip something. We're going to skip one little piece here. We're going to see it in pre-calc. We can at least talk about that it exists. But I'm not going to make you guys test on it. We're not going to present it super hardcore this year. Check this out. I'm going to zoom out really quick. And I want to notice something. On the first example that we did on A, it was a cubic function. It was degree 3, right? How many roots did we find? Huh. Okay. This one was a cubic function. How many roots did we find? 3. What if I give us a quadratic just randomly? And we don't actually have to do this, but if I give us this quadratic, does this factor? This is a quadratic function. It factors as with a shortcut. How? How does this factor if we use a shortcut? This quadratic. I just made up a new problem just to look at it. Leading coefficient's 1. I need factors of 2 that add up to 3. I think it's 2, right? So check that, and if we've not seen this connection yet, this is a super helpful one. If it's a 3rd degree function, it had 3 roots. Our quadratic is a 2nd degree function, and it had how many roots? Now, even in the situation where it's like a perfect square, and we've seen that, and it's happened, if we have x minus 1 and x minus 1, how many roots would I actually list? So there's only one number, it's x equals 1, right? But do you agree it repeated? It has a multiplicity of 2 is how we would say that. So still a quadratic had 2 roots. I'm going to go out on a limb here. If I give you x to the 4th, how many roots are there going to be? 4. Seem reasonable, the way it's shaking out? They might repeat, they might not. But what we have just stumbled upon, or I pushed you directly into, I don't know, whichever wording you prefer, is a very important idea in mathematics. And it's important in algebra. It's important in pretty much any field of math beyond this. We are going to get 2 really quick theorems, and that is not algebra. 2 quick theorems, and the rest of the time is going to be yours. So, okay, got me good. First theorem. I just want to make sure that we get it. It's not that. Man, there's some ugly stuff in here that we're not doing. Okay, so we get 2 additional theorems really quick, and I'm just having a hard time finding them. I'm sorry. Here we go. Okay. So we get 2 really important theorems here. Okay, the first of these is so important that you're going to be able to tell by the name. And we just have 2 theorems to write. We don't have to do any more problems. But here we are. Big important ideas at the conclusion of this section. The first of these is known as the fundamental theorem of algebra. Okay, can you tell that it's an important idea?
No.
Why should you be able to? What does fundamental mean? So I definitely emphasize fun, right? Because we're in algebra. But important, the basic, the foundation. The fundamental theorem of algebra. Now, this is produced in a few different ways, but here we go. A polynomial function, and I don't know, there we go, a polynomial function of degree n has n roots. Now, the weird part of this, that we're not going to get to see all of it, but they could be real numbers. They could be imaginary numbers. So the real theorem says has n roots in the complex numbers, but the complex just encompasses both. There's n of them. Now, one step further, and I would call this a corollary, which is just a follow-up to a theorem. But if we're going to get an I out of our stuff, out of a quadratic that we're solving, we probably had to use the quadratic formula. Do you guys agree with that? And all I want you to do is tell me what I've forgotten about the quadratic formula here. And you don't have to write this yet. I'm just trying to think it out. I've left off one important mark here. If this winds up negative, do you agree that very clearly one of them is going to be something plus something with I and the same thing minus something with I? So if I ever get a single complex root, because it's plus or minus, does it sound reasonable that I'm going to get another one for free? So if I get I as a root, it could be 0 plus I, that's it. But I also would have found 0 minus I. They always come in pairs every time. They can't show up any other way. This as just a follow-up, and we'll just put one additional comment. If a function, a number, what do you mean? N? Just a number. If it has degree n, so if there's a 5th degree function, that has 5 roots. If it's a square or a quadratic function, it'll have 2 roots. Cool. If a function has, and I'm going to write this, there's more to it than we're really going to see, a plus bi, and I'm going to say x equals a plus bi as a root, which again, just using this quadratic formula, if I use the plus part of it, what's also going to show up? The minus part of it, right? Or the negative. If I have this complex root, then its conjugate, and what is, and this is an old one, but what's the conjugate of a plus bi? Instead of plus, what do you think I should write? Good. If a plus bi is a root, then its conjugate, a minus bi, is also. Now, your book calls this something like, they give it its own name. It's called the complex conjugate theorem. Don't care what it's called. They show up in pairs. Now, we get to see all this again in pre-calc. If my computer's so dirty. If you have me for pre-calc next year. If you don't, you might see this depending on what you wind up taking. Okay. The rest of the time, I'm going to give to you guys. Have we done any problems from this section? Did I give you homework last night?
Yeah.
I gave you that one problem, right? Sure, you're right. Okay, I want you guys to do homework 3.5. Hey, me too, man. Page 165. And I want you guys to do, okay, I want you to read the directions very carefully when you're doing these, okay? Like, don't do more than you need to. Is this 3.6?
Who knows what we're on?
Well, it's just continued from yesterday. It is 3.6. It is 3.6. I'm sorry. I hate that 6, but I'm not going to change it. 3.6, you'll find this on page 165. And I want you guys to do problems. I think we're ahead of first hour right now because of map testing. 21 through 29 odd. Just kidding, 21 through 27 odd. Okay, for this, I'm going to make a note about these last couple. Nope, I'm good. No comment. If you need it, just throwing it out there just in case. Maybe, just maybe you'll use this on a couple of them. Maybe. Gosh, my computer's so dirty. The quadratic formula. Oh, my bad.